Welcome to Revolutions, the show where we get into the details of the gear industry. I'm your host, Randy Stott, and today I'm here with Udo Stolz of the Gleason Corporation. Welcome, Udo. Thanks for joining me.
Thank you for having me.
Today we're going to talk about gear skiving. So, Udo, how has the technology for power skiving changed over the last several years?
Well, the technology is not new, so the technology has been introduced 50 plus years ago. The initial patent is older than 100 years. But actually, the technology didn't pick up because of the missing stiffness in the drives of mechanical machines. Well, in the last few years, I have to say that the situation has changed completely. Now we have direct drive systems which allow a perfect synchronization between the tool and the workpiece. And in connection with very stiff machines, very stiff work holding, we have the prerequisites to have a successful power skiving process. But machines, work holding is not the only thing which is important. What is very important is to have a good knowledge of the technology, to have the possibility to simulate the process before you have removed the first chip. And that is actually also the base to design a competitive and a performant tool. So in Gleason, we are designing the tools always starting from technology. So we do a simulation, and then the fine-tuning is done by the tool supplier. We have the benefit having a tool supplier in the Gleason group, which is Gleason Cutting Tools Corporation in Rockford, here close to Chicago. And thus we think that we have the key for success for power skiving. We have started several years ago. We have started with rather simple applications, but we have now moved into more sophisticated applications, including shafts, larger workpieces, but also hardened workpieces.
Now, you mentioned a couple of things, but are there other applications that have opened up in the recent, with the changes in technology?
Yes, I'm going to mention that, but before saying that, I have to mention something else, what has also happened in the last few years. So smart tool development has enabled us to use the power skiving tool or the backside of the power skiving tool for chamfering. We have also tool combinations where we can chamfer or we can deburr the lower side of the workpiece, but we also can deburr a groove if that is applicable. And last but not least, we have closed loop implemented now since quite some time for cylindrical gears. And the beauty of a closed loop is that we are enhancing the capabilities of power skiving because we have the possibility to measure the gear and to transfer the modifications very easily and very fast to the power skiving machine. And so now to your question, a classical application which has opened in the last few years are internal ring gears. That was an application where in the past, the ring gears, they were soft machined, and then they were, we had soft manufacturing of the gear, but that was all. So maybe it was not necessary, but we also didn't have maybe the means to do a hard manufacturing of the internal gear in an effective way. In the last few years, we see a tendency towards fuel economy, but also we see a tendency towards noise reduction. So you need gears which are fine finished. And that's when hard power skiving came up. And hard power skiving seems to be the technology to cover these needs.
Now, how does the quality of hard skiving compare with other gear finishing processes? And can it be used to replace grinding?
Well, that is not an easy question, and it needs a differentiated answer. So if you have external gears which can be ground, I would probably go for grinding as a fine finishing operation. If you have external gears which have shoulders, you have two possibilities. One is power skiving, if you have enough space, or honing. So depending on the requested quality of the gear, you can do either one or the other. For internal gears, power skiving seems to be the method of choice for hard manufacturing. Of course, you can do also honing, but honing is not a very efficient process for internal gears. So that's why we think power skiving is the method of choice. I know that we have competitors who state that power skiving is the solution for almost everything, but I wouldn't share this opinion. I think that all the other processes like hobbing, shaping, broaching, grinding, honing, they have so they are processes which we are going to see in future. But of course, power skiving covers a special niche of gear manufacturing, and so we have the benefit of having all these processes, or most of the processes, in our portfolio, and having the benefit to give our customers the best possible advice.
Okay. Now with skiving, what tooth forms are possible, and what kind of tooth modifications can be achieved?
Basically, all tooth forms which can be generated. I wouldn't say 100%, but well, I would say 90% of the tooth forms which can be generated can be manufactured by power skiving. The beauty of power skiving is that on one hand, we have a productivity increase compared to shaping, and we have flexibility increase compared to broaching. So it is very easy to generate lead modifications like crowning or taper by power skiving. You also have the possibility to do certain profile modifications by the axis, by some axis movements. So power skiving gives you the possibility to do certain things which are not possible with other processes.
Okay. And what are some of the advantages in terms of productivity and efficiency?
Yeah, what I mentioned, so related to shaping, we see productivity increases in the range of 2 to 6 times, depending on the application. So sometimes it is only 2 times, but sometimes we see tremendous benefit in terms of productivity. And the beauty of power skiving, especially for larger modules and larger sizes, talking about sizes like 600 to 800 millimeters and module up to 8, we see also tool cost per piece saving compared to processes like profile milling or shaping.
Okay. And are there advantages to having a dedicated gear skiving machine compared to a cylindrical or a bevel machine, or even a multi-axis turning center or machining center with skiving capabilities?
Yeah, the question is, what is a dedicated skiving machine? So I think it is nothing bad about using a hobbing machine or a bevel cutting machine as base for a power skiving machine. But we have also learned during the years that the forces which occur during power skiving are extremely high. So the machine without any changes is really not so suitable. So we had also to learn it the hard way. During our learning curve, we had to do re-engineering of certain components and sub-assemblies, so to make the machine suitable for the power skiving process. Now, in general, gear manufacturing machines are more robust and more stable than turning machines or machining centers. But that doesn't mean that power skiving is not possible on these machines. But I still think that power skiving on dedicated power skiving machines is more productive than on machining centers. This might not make a big difference for small lot sizes, but I think it makes a difference for larger lot sizes up to mass production.
Mm-hmm. Very good. So who should be looking at this technology?
Actually, everybody manufacturing gears.
Mm-hmm.
So we had, in the last 10 years, we had many different applications. So we have developed solutions for people in motorcycle industry, passenger car industry, truck, agriculture, construction, industrial gearboxes, and aerospace. So what is also very important, the manufacturing process is really determined already in the design phase. And since about 1.5 years, we have the company Kissoft, which is one of the market leaders for gear and gearbox design. They belong to Gleason. And our task is to implement more technological know-how in the software. So one of the things which we have started to implement is power skiving friendly design.
Mm-hmm.
So basically you can already see in the design phase if a gear can be power skived or if it has to be shaped. And this, of course, immediately gives you an indication about the cost of manufacturing. So this is part of our strategy to be the true total gear solutions provider.
Very good. Udo, I'd like to thank you for joining me today. Appreciate your time.
Well, thank you for having me, and thank you very much, and I wish you a good rest of the show.